To answer some of the biggest questions about what's out there in the universe and what it all means, we need powerful telescopes. NASA unravels the mysteries of the cosmos using observatories in space that study the different wavelengths and properties of light. The Imaging X-ray Polarimetry Explorer, or IXPE, will study X-rays from some of the most extreme objects in the universe, like black holes, in a new way. IXPE will look at a special property of X-rays that has gone mostly unexplored until now. It's called polarization. X-rays come from the hottest places in the universe. Imagine powerful explosions, violent collisions, and strong magnetic fields creating chaos in the darkness of deep space. X-ray telescopes can trace clouds of gas heated to millions of degrees and detect the shower of particles fueled by a feeding black hole. Building on the discoveries of NASA's Chandra X-ray Observatory and other space telescopes, IXPE measures the orientation of X-rays from some of the most brilliant and bizarre objects in space. Like all forms of light, X-rays consist of moving electric and magnetic waves. Usually, the peaks and valleys of these waves move in random directions. Polarized light is more organized, with the two types of waves vibrating in the same direction. You might have heard of polarized sunglasses. Boaters and fishermen use these lenses to reduce glare from sunlight across a body of water. Water reflects light in a way that causes some of it to vibrate in a direction parallel to the water's surface. Polarized lenses block light moving horizontally, but let other light through. Much like the way light changes when it bounces off of water, in space, light becomes polarized depending on where it comes from and what it passes through. By measuring the amount and direction of polarization, IXPE gives us clues about the shapes, structures, and inner workings of all types of objects that shine in bright X-rays. The IXPE Observatory has 3 identical telescopes with 3 main parts: mirrors, detectors, and an extendable mast, or boom, that separates them. Each mirror assembly contains 24 nested mirrors that collect and focus X-rays. Located at the focal point of the mirrors, sensitive detectors made with international partners in Italy are the secret behind IXPE's unique X-ray vision. They track and measure all 4 properties of incoming light: its arrival time, direction, energy, and most importantly, polarization. Over the 2 years of its prime mission, IXPE will observe more than 50 brilliant objects, like the leftovers of huge stars that exploded into supernovae, the supermassive black hole at the heart of our own Milky Way galaxy, and pulsars, the dense remains of stars that once were. These observations will help scientists tackle long-standing puzzles, like testing competing theories about pulsars and the details of how Einstein's theory of general relativity works. New insights from IXPE will help us paint a fuller picture of the universe, confirming or confounding our thinking in the years to come.